Thanks for inviting me up here today. It's much appreciated. So my talk's on Mongo. It's a database that I love, and I think it's because I hated doing ETL scripts on SQL for so long that I kind of fell in love with Mongo because it's more like kind of developer focused. My clicker thing's not working, which is is that not working? Oh, it is now. So this is a bit about me. So I'm a software developer in my day job. I'm also a Microsoft MVP. I am a Mongo champion. I work at a company called Cresco, which is a payments company down in London, which is a startup. And I run two .NET groups as well. I run .NET Sheffield and .NET York. So if anybody's in Sheffield or York, we usually run them the first Tuesday or the first Thursday of the month. So feel free to come along with them. I also kind of help out and do some open source projects as well. And yeah, I've got some social feeds. So if anybody wants to follow me on Blue Sky, I got told it's loads of people at the weekend say it's B Sky or Blue Sky, and I think the consensus of it's people should pronounce it Blue Sky, not B Sky. I don't know, but feel free to kind of follow me on that as well. That'd be great. So today I want to go over the kind of like the database trends in general, kind of what is MongoDB and kind of how it fits in the market, the document model and the flexibility of it all, and the different types we can use. And then we're looking to go into a bit of like kind of like the modeling between documents compared to the more relational database. And then we'll again just dive into kind of how you can use it in .NET. And there's two ways to use it. There's the EF provider and the MongoDB driver. So a bit of a review. So Mongo is like the most trending like kind of database. Document database, sorry. And over all databases, it's just below all the kind of Postgres, MySQL, MSQL, Oracle. So obviously it's not beating them because they've been around for so long and everybody uses them by default. But for a modern database, Mongo is like ahead of the curve for everybody else. And this is just taken from the dbengines.com, which shows you a bunch of stats about kind of what people are using and what's trending in the market. So just put your hand up if you've heard of what MongoDB is before. Everybody, awesome. So Mongo is just a general purpose database like SQL Server or kind of MySQL. The idea is it's trying to solve lots of people's needs without kind of just allow you to do your job and get your data stored and kind of get it back in an efficient way. But compared to most traditional databases, it's document-based, and then documents are stored in BSON. So a lot of kind of document-based databases are stored in JSON, and we'll talk about BSON in a second. And the idea is you implicitly normalize your data. So instead of kind of trying to like normalize it in third normal form, we just roll things up into kind of the document. So if you have a person with an address, the address just goes straight inside the person object. And the idea is it's built for the cloud, so it's like unlimitedly scalable and can be like kind of sharded and partitioned out as well. So BSON documents, the kind of fundamentals of how Mongo works in the hood. So everything which is transferred over the wire is a BSON document. So that's any kind of operation, any data, what you kind of passing into the database to be stored is all BSON. And to have it like such a rich experience over the wire for the communication, we have lots of different types we can use. So compared to like JSON, JSON only has like a Boolean, a number, a string, a null, and that's about it, I think, an array, which you can actually use. So they actually have real like number types. So a number in JSON is just represented by a digit with maybe a dot with another digit. As kind of like BSON documents allow you to store properly like decimals or doubles or singles and stuff. And you can also store things like dates as well. So then you can index on the dates so that you can have better performance as well. So Mongo kind of still has a schema. It's not like schema free. Everybody says like Mongo is like schemaless or schema free. But you still have to have a schema to your data, because if you put your data into a database and you're trying to get back out, you need to know what you're getting back out. If not, it's kind of like flawed. But it does mean you can have like different types of schemas in your database at the same time. And also there's no kind of upfront defining your schema. So with a lot of relational databases, you kind of like set up the schema with a load of scripts to declare like kind of what the table is, how long the column lengths are, etc. As in Mongo, you just throw the data in there, and it'll just create the schema dynamically, which allows you to rapidly change the data. So if you're appending any kind of properties to your model and they're not breaking, but obviously breaking changes will still need like kind of migration scripts or something to kind of deal with that further down the line. Which obviously makes less overhead in the general long run. So when you're developing software and you're trying to add extra things to a model, you can just kind of put that data on there and just ship your software and it'll just work. There is a way to kind of validate what you push into the database. And a lot of like dynamic languages use this, so like JavaScript and Python. And that's because like if you're taking something from your API and it's just some JSON, and then you're just throwing that straight into the database and convert it into BSON, you could just end up with any old garbage in there. So Mongo has a schema validation built in. If you want to validate it, it's based on the JSON schema as well. So you can give it a JSON schema to say when you insert anything or modify anything and it violates the schema, you can either give warnings in the console, or you can just throw back an error and just say, this is not in the database, I don't want it. But usually when you're kind of like working with like C# or more typed language, we use the typed like classes and things like that to define our kind of schema instead. These are my voice. So this is an example of two documents inside of Mongo. So they're pretty much the same. So you've got an ID, an underscore ID, which is like Mongo's default for the primary key. And Mongo normally creates this as an object ID, which is kind of like a GUI, but smaller and monotonally increasing as well. And the name is both on both sides, and you've got an age, but you've got a difference in kind of like the GitHub ID, and you also have the Blue Sky ID as well over here. And they'll be totally valid documents to push into kind of one collection inside of Mongo. And you can model these in different ways inside of C#. You could have some polymorphic objects, or you could just literally have like give the GitHub property, which is nullable, and you could have a Blue Sky ID, which is also nullable, and they're both perfectly valid two ways to model it. So for kind of modeling kind of your documents, you probably want to like look at your application usage over trying to split things into bits, which is completely different kind of perspective on normal like relational databases. And the idea is you want to kind of all your operations to be on a single document. So if you roll things up to be every atomic operation where you're applying to your system to be on a document level, then you won't need things like transactions, etc., which you will need on like relational databases because you can span over different tables. So we try to kind of embrace rolling up as much data as possible into a single kind of document. And if you've got like small kind of documents as well, it's actually more efficient to actually roll them up into like a per hour, per minute kind of document as well, just for performance. That means you don't get like massive indexes and things really. And yeah, so you roll them up. So if you had like different logs coming into your into Mongo, you're pushing logs into there, you might want to roll them up into like a per hour or per minute kind of document instead. UTCs are times roll UTC. So like most databases, it does deal with time zones. So if you need to convert them to do comparisons in the database, you can do that in like aggregation pipelines. And also arrays, this is a big one. Arrays can also be indexed. So a lot of people try to split the data apart because they think it's like a relational database. So you might have a person with multiple addresses and they put them addresses in another collection because they want to index them. But you can just index an array. So if you got like you want to search on the first line of their street address for their array of addresses, what they've got in that document, you can just put an index on that and it'll create multiple indexes underneath it so they can be queried efficiently. So it's one of the things what people kind of fall short of. So if you look at a normal traditional kind of example of like a relational database, this is a blog site. So we start off with an article, which actually has an ID, an author ID, a title, a summary, and text. And this is usually linked to like another table, which is the author, which has their name and bio on it, with also an ID. And then our comments will also have an ID for the comments, which links to the article ID and some text. And then the same thing for if you have tags on there like C#, like Docker, whatever else. We'll also have a tag collection with all them like distinct tags, and then we'll have like a joining table in the middle of it. And straight away, like we don't really want the kind of the tag ID and the kind of comment ID are just there because we live in a relational world. I can't remember the name of that. what the IDs are called. But if you look at it from like a document perspective, you look at the use case. So you pretty much look how you're using it straight away. And if we look at our blog site, we've got our article title, our article text, the comments, the tags, and the author in it. So what we do is just like kind of just throw that all into one document. We don't really care about kind of like disjointing it all, because when we try to get an article, we're going to use all the data anyway. So we just put it all together. So that means we can have our ID, our title, so we can find our article. We've got our title, summary, the text of it, and then we got our author information, which we just put in another subdocument. And then the same thing for the comments. That's just an array of like subdocuments, and the tags are just an array of strings instead. So that means that if we want to search on a tag, we just search on the tags where they have like events, for example, and we could also index that. Some of the times you want to kind of like make a hybrid approach as well. So you might want to store the author information on the article, like a subset of it, and then we might have like some kind of like collection which actually stores more information about the author. And this is quite useful if you've got like an author's page which has loads more information about the author, but you don't want it for the articles. And you can keep these in sync if you're using like some event-based system as well. So that's pretty much about kind of like some basic kind of like foundations of like kind of Mongo. And we can go into like looking at the how Mongo fits in with like kind of .NET. So one of the kind of like newer kind of things in Mongo is the Entity Framework Provider, which is built on Entity Framework Core. This is a version 8.2. I think the first version was actually 8. So it's only moved on about 2 versions. And this was like a collaboration between Mongo and Microsoft actually as well. So they both teams actually worked on this to produce the actual EF provider. So just put your hand up if you've used EF before. About 50% of people. So Entity Framework is a ORM, so it pretty much just the idea is it maps your database into objects, so then you can interact with them, and then put your behavior in your documents, your objects, sorry, in memory. So the idea is it maps from the database to your C# code, so you can kind of like set up all the kind of math bins, and EF has like a default kind of convention built in. One of the other really cool things it has is train tracking as well. So you can go get your maybe your article out of the database, you can change it, and then you can just call save, and then then it works out kind of what's been changed in that actual in that class, and then it'll just go create you the kind of update statement and then go apply it to the database. So you don't actually really care kind of like how you're tracking your changes. You don't have to kind of like think, oh, I've updated the name, I've updated the author, then I have to go save that into the database as well. It does all that kind of for you, which obviously creates hyper developer productivity because you've got an abstraction layer from you and the database. So you don't need to know, like, for example, currently like SQL, for example, you don't need to care about how you write SQL update statements or select statements. It writes them all for you. Same as the Mongo EF provider also just writes all your Mongo queries for you and all your update statements and etc. as well. You also get the advantage of using links, so it has a link provider built into it, so all your link queries just kind of work by default. And it has also the optimizations for like things like lazy loading, the caching, and yeah, eager loading as well. So you get all the kind of like benefits of that out as well. So normally we kind of create our models like this. So we got this is like a pretend insurance kind of API we're building up. So we got like a policy which has an ID, which is a GUID, a policy number, a policy holder, a premium, and some claims on it. And the claims are also another complex type, which actually has an ID, a decimal of an amount, and a description as well. So we just declare our kind of like models as we just do in the C# code. We then can create our DB context, and this is exactly the same as a DB context as if you're using MySQL or SQL Server, for example. We create a DB set on it as a property, and this will get filled by EF itself. We pass in the DB context options and just pass them straight into the base. And then we have this override, which is on model creating, and this is where we can configure our mappings or kind of our conventions, which we want this DB context to like kind of use. So one of the differences here is like the builder normally has a 2 table on it, and in Mongo we have a 2 collection. because the terminology is different. So like normally relational databases work in tables, Mongo works in collections. So we just have a method which is 2 collections. So very similar. It also can deal with optimistic concurrency as well, similar to like any of the other EF providers as well. So we can give it a concurrency token, or we can give it a row version as well. The concurrency token is just a hash, I think it is, and the row version is just a monotonically increasing integer. And when it does the update statement to the database, it just makes sure that's the same version as what it actually pulled it out of the database. And if it's not, it just throws a concurrency exception, and then you need to load it and then apply the changes again, so you don't get people standing on each other's toes. So that's built in by default, the same as the other providers for EF. And then to kind of set it up in our application, we just register it into IRC container. But this time we just use the use MongoDB, which changes it to use the MongoDB provider. And then also we pass in this Mongo client, and this is the kind of the raw driver for kind of Mongo. And then it just kind of works. And then if we want to kind of create some documents, we can go get the DB context out the IOC container. And then we can go create a policy by just newing it up. We can add the policies to the policy collection, then this call save. And this will just deal with all the kind of the insert statement. You don't need to write an insert statement. You'll just translate that into the Mongo kind of query language, send it to the database, apply it, and then come back. And then if you've got IDs and stuff like that as well, you'll just automatically update them as well on there. So that just works as you expect it to, and the same thing as the abstraction with the SQL one. You don't need to know about SQL to actually use it and store your data. Also, you can write link queries to get your data out. So you can say where the policies, where the premium's over 100, and then just async them. And then that'll just send the query to the database to fetch them, and then just map them all back into memory based on our policy class as well. Updating documents is very similar to kind of the before. So we can go fetch our policy where the policy ID is a certain ID. We can go create a claim, and we can go add the claim to our policy because it's just a collection, and then we can just call save changes, and then that'll just automatically kind of update that document in the database as well. So now I've just gone through that. I'll just show you a bit of an example of it working. So I have, this is Mongo running in a Docker container, which is just ticking away in the background. This is the Mongo shell. There's GUIs for it, but I just like white on black. So it has the same concept as if you'd kind of like terminal into SQL Server or something. You can show all the databases. So these are databases what I've got. I've got admin, config, and local. You can see that. So I don't have any databases there, which I'm actually storing any data in at the moment. So if you flip over to my C# code, I built up a small minimal API here because I work in API land. So this just creates a Mongo client here. And then we can set up our DB context. So we pass our DB context, what we saw in the slides, into the IOC container. We can build it, and then we can map a group of policies. And then we can take in a policy. I'd advise not using the same domain objects as your DTOs for over the wire, but this is demoware. So we take in a policy. We change the ID to be a new ID in case anybody's changed it. And then we can just add it to policy collection and save it here. And then we can just return 200 OK with that policy in it. We can go query the /policies with a policy number if it's there. So we can do a bit of a if statement here saying if the policy is set, then go find the policies where that policy number is that value, else just return them all. And then we can to-list async them all, and then return that in OK as well as an array. We can get an individual policy ID where the policy ID matches, and just go fetch that out of the database. If it's null, we return not found. If it's OK, then we just return the policy. And then we can also add post claims to our policy as well based on the policy ID. So we're taking a claim, taking the policy ID. We go find that policy. If the policy is not there, we just say not found. If it is there, we can set a new ID to it, add it to the collection, and just call save changes async, and that'll update it. So if we just run this, I have a HTTP file over here. I don't know if anybody's used these before, but I also don't like Postman because it has this like GUI interface thing. So so this is like raw text, which is awesome. You can commit into source control. So if we post to a policies endpoint here with a policy number, a policy holder, and a premium, we can call this, and this will return back and say like, yep, all good, I've just created it, and here's the actual one I've just created with a new ID. I didn't set up anything in the database at all, but if we now go look at all the databases in here, we can see like insurance demo 1, which is the one database what I could connect to, just magically appears. So we can go change over to use that database. So it uses the same commands as SQL, amazing, use, that's great. So then we can share the collections in this one. So this has got policies, and then we can just go look at this policies collection here by just doing a find. So this is the one that is just saved, and then we can also post a few more in there, and then we can go find them, and they're all in there what you expect. So they're nicely just stored in my database. I didn't need to learn any Mongo magical query syntax to do that, and they're just there. And also, I didn't have to set up any schema or anything. It just kind of created the database, created the collection, and created the documents for me without even looking at it. So if we go to those other ones, we can query based on the policy number. So if you go do a GET request on there, this will return back just that policy because it's filtered it out. But if we emit off there that policy as well, and just run it again, we'll get all the policies in that as well. So the filtering just works based on link. We can get a single policy based on its ID, which is not that one. Let's get one of these. I did this talk at the weekend, and I was like, I should put these as variables, so I don't have to copy paste GUIs over it. But yeah, so we can get a single one based on its ID, and that comes back fine. And then we get the fun part of like we can post in a claim into our policy. So we can just replace that on the again. So we're going to post the policies, the policy ID / claims. We're going to pass a claim into it, so amount of 199, and the amount of water to leak in the kitchen. So we can post to that, we get a response back, and then that's just stored as well. And then if you go look in our collection over here, all these ones have claims which are empty, except this one here where it's just add this claim for me. So again, like I didn't need to do anything fancy to push that into an array. It just kind of happened. And yeah, that's pretty much it. So that's EF as a nutshell with Mongo. So it's by default, it just kind of works out of the box. You don't really need to care about kind of where it's storing the data. You just kind of configure it, and it just kind of works. Obviously, it has like its downsides, as like if you're using the SQL Server one. So for example, like this policy, when we go add a claim to this policy, we're going to find the policy, and if this has got like a massive policy document with like hundreds of fields, and then all we're doing is like adding a claim to it and then saving it, we're just pulling all that stuff across the wire, and we're using tons of bandwidth for no apparent reason, and then just throwing it all in the bin after mapping it. So we're using all that compute to map it into an object and just throwing it all away, which is just not very efficient, really. And that's the same concept. So like people moan about like the EF in general. You don't kind of get the bare metal, but it's an abstraction. That's the whole point. The idea is to let you go faster, not have to learn as much kind of like knowledge about SQL in the first place or Mongo, and just allow you to like kind of produce your application fast, get it out to market, and then maybe reiterate. So for like SQL, people drop back into using Dapper for more complex and more performant kind of queries. And in Mongo, you drop back into using the driver natively. So the next bit is just pretty much the driver. So things what you can't do in EF, you can just use using the driver. And like most of my experience of actually is just using the driver. So the EF provider's only been out for about a year and a half. But the driver's been pretty much there since day one. And this was like the default way to interact with the database. But the problem with like having the driver, you need to know kind of the like a lot of the terminology about Mongo, and also kind of their operators for their query operators, their updater operators, etc., which makes it a bigger learning curve. So it's the driver is built around kind of being more document orientated. So you can actually just new BSON document and just throw it into the driver, and it'll just go throw it to the database. And so you can actually just do any operation you like, including commands to the database. It also has less overhead, so like because you can specifically say what you want the database to do. So for example, the claims being pushed inside of the policy, we can just say go push that single thing into an array. You don't need to kind of like go download the whole thing. It also kind of has native support for the aggregation pipeline, which is a really powerful kind of way to kind of manipulate your data in Mongo. It has support for the transactions. So when you're doing multiple operations over many documents or many collections, you can actually start a transaction and commit it all together. By default, EF does wrap your operations into a transaction. So if you go fetch like 3 objects outside of Mongo, map them, change them, and save them all together, it'll wrap them all in a transaction. It has native BSON support, so there's lots of different types which C# doesn't know about, which Mongo supports, and you might need to know about them types, or might even need to know about the field doesn't exist. So, for example, C# can actually only tell you if a value is null or it exists. But also in Mongo, there's a thing like it doesn't exist. So it has null, doesn't exist, and it exists, because null is a type as well. You have a bunch more like query operators, so you can do like element matching inside an array. You can do regex over things. You can do geospatial queries. You can do vector searches and other kind of like operations on your database, which LINQ doesn't support. And then you also have pretty much full control of the whole schema what you're dealing with. So the models what you kind of create are pretty much identical. So we can create like, I think EF doesn't support immutable types as well as the driver does, but they're pretty much identical. So like, for example, we can create a policy which has the ID, the policy number, the policy holder, the premium, and then the claims on it. And then that claims is just a record as well. Pretty much identical. And the driver supports these things called conventions. So it has a bunch of conventions built in by default to deal with like mutable types, how to new classes, what constructors to use, etc. You can actually create your own conventions, or you can actually pick a bunch of them out as well. So this just sets up a convention pack which says use camel casing for your property names. So by default, the C# driver uses Pascal case. And then you can also, if you want a less performant database, you can actually change your enum representations to be strings as well. So if you want big indexes and things like that, because they're just full of strings, you can also do that. And then you kind of apply it based on its name, the type. So you give it like a predicate, which is a callback to say if it's true and false, if it should be applied or not. And you can also override the mappings for your objects by calling this BSON class map, reg class map, and then you pass in the generic type into it. So our policy, the first one, which is auto map, just means run all the conventions which apply to this this type. And then you can then override them, say like, oh, for the policy holder, I want to set the element names, the field in the database to just holder. And then you can also set different things like the serializer and things like that. So if you want your amount to be serialized as a decimal 128 BSON object, then you can do that as well. And then if you want to put it into ISE container, you just add it all as like singletons mostly. So you add the client, the Mongo client as a singleton. You can have the database as a scope. So you can do on the client, you can do get database, which just gives it a string. And then for the collection, you give it a generic type of your class, what you want to kind of pull out your collection. And this can be polymorphic as well. So by default, Mongo will also create you like an _T field inside your documents, which is a convention, if you've got a polymorphic objects as well. And also, if you want to just have the raw BSON document representation back over, you can just BSON document into there as well. And then we can just start using it like we did with the EF provider. And this is very similar to EF. So you pretty much just get the collection at the IOC container, you create a policy, and then we can just call insert one async and then pass in the policy into it and await it. And that'll just send that data, that operation straight to the database and execute it, come back with the result. The same if you're querying it. So we can also pass in an expression to say whether ID is the policy ID, and then do a first or default, which will actually get converted into a BSON document and sent over the wire as a Mongo query. Or you can start using these things called filter builders. So builders here as a generic class, which has a bunch of kind of methods on it, such as filtering and updating. And then also these have like expressions, or you can use another document inside of it. So you can say like whether ID equals the policy ID. So this means we can start build. These are the kind of more mapped to kind of how you declare operations in Mongo, in the Mongo syntax. So then we can pass that to find as a filter and then do a first or default. So very similar to kind of how like link works, but the terminology is starting to differ. So we have things like find and EQ for equals. And then we can start building more complicated querying logic. So we've got like where a filter on the policy where the premium is over 1,000. And then we can use a Boolean AND operator as well, the bitwise AND operator, to actually join multiple filters together. So then we can join it with an element match. So you can say where any document inside the claims array matches another builder where the amount is greater than equal to 100,000, and use that as a filter. So that means we can actually build up more complicated filtering on our documents. And then we can also do text-based filters as well, so text-based queries. So you can say where crash is, do a text-based search in the document where the word is crash. And then we can also check where like fields exist as well. So you can say, does the premium field exist in this document? Which obviously you can't do in link because there's no such thing. And then we can also start using the aggregation pipeline, which is very similar to how link is, but this is matching to the Mongo syntax. So you can call .aggregate on a collection. We can pass in a match, and this expression for the match can also be the filter builder or just an expression. We can do a group by, and then we can do a match and a project and a to list. So this will get all the premiums where they're over 1,000, group them by the policy holder with the count of how many policies that policy holder's got. If they've got over 5, it projects out their name and then just to list them as a big long string. So updating is very similar. So we use these things called the builders again. So we do an update on it. So we can create a new claim. We can call push to claims for this claim. And then we can do a filter on the policy ID, and then I'll pass the update into it as well. And then the filter can either be the expression or the builder as well. So that's the alternate example of that. And then last of all, delete is just an expression as the same as find. And we just call delete one async, and that just goes and deletes the document. Transactions, so implicitly Mongo the driver starts a transaction, a session every time you do an operation to the database. So if you do an insert, a select, or whatever, you'll create a session implicitly every time you do that operation, but you can actually create a session up front yourself. So this is where this client.start session async is. And then on a session, you've got like a way to start a transaction. And once that transaction is started, you can then enlist operations on that session. So the update one, you can pass a session into it. So the first argument for all the kind of updates, selects, deletes, etc., is always the session. So you can pass the session to it, and then that operation will be enlisted on that session, which is wrapped in the transaction. And then when you actually finished, you can just call abort or commit transaction async, which will just do all the operations together. So look at that. So I've got the exactly same API over here, but written as as just using the raw Mongo driver. So we new up a Mongo client here and put it into the ISE container as just a singleton. If you new multiple ones of these up, it deals with all the connection pool inside there anyway. So you'll only get one connection pool, even if you create 100 Mongo clients as well. It's based on the connection string, so it keeps internal. So if you create 3 different connection strings, which are unique, then you'll get 3 different connection pools. We can pass in a database into ISE container as well. So we just get the Mongo client out, call the get database with the string of the database name, and the same thing for the collection we saw on the slides. And then this is exactly the same as before. So we have one where we can just post the policies, does the same thing as change the ID, just inserts one, and then just returns the policy. This uses the aggregation pipeline instead. So it just calls .aggregate on there. If it's got a policy number, you'll just do a .match based on the policy number, and then call the toList async, which will just execute that. For the policy as well, to get by the ID, we just pass an ID using the find method and do a first or default async to get the first one. And then if the policy is null, we just return the right things. And then the claims, this is a kind of like the more performant one. So we pass in the policy ID and the claim, and then also we've got the collection. We go update the collection, so we don't need to go fetch the policy anymore. We can just say go update the policy. So we match the policy based on the policy ID, and then we can say like where the policy, once you found that policy, go push in this claim into it. So it's just going to push the claim what we give it into this claims collection when this predicate's matched. And then we can then get the result back out of there and say, if we've not matched any policies, which is in our collection, then obviously that policy is not found, like before. And if we have, we've successfully kind of put the claim into that collection. There's also things on here as well, so there's lots of different operations to kind of do tons of different things. So there's actually things like add to set. So if you have the identical claim in there, and you do an add to set, it's only going to add it once. It's not going to add it like 10 times. If you apply that update statement multiple times, it's just going to add it once. The push just pushes it straight into an array with without kind of checking what else is in there. So we can just do a quick example of that one. So remember, we don't have any databases which is called insurance demo 2. So as soon as we go post something to that, we just post that policy, this will get straight away the insurance demo 2 collection database. Which will have the policies in it. And that's pretty much identical as before, mapped across. And then we can just do the same thing. So we can do the filtering and get that straight back. So it's perfectly fine. Getting the single policy. Looks exactly the same. We can post some claims into here. So then if you look back over here, also have a bunch of claims that are post in there, all exactly the same with what you expect. So the driver just allows you kind of just drop back into the more native Mongo and kind of deal with whatever you need to deal with. And if we look at the, so for example, where's the find one? Yeah, so we've got the find here, which is using an expression. So this could actually be changed to be using the builders for the policy. Yep. So you can pass that straight into this filter instead. And that'll work exactly the same because it pretty much boils down to the same thing. But you can also, stop this. But you can also pass, so this is building like this is like a C# kind of like type safe way of kind of building up the Mongo queries. But if you really want to, you can actually just go and you have a BSON document, right? Which is just the BSON, like a document in its own right, and just pass that straight to find. And I'll be completely happy with that. And the reason why is because you can actually just set, oh, that's not there. Here it is. Copilot's trying to help me. Ah. Wait, why is that there? I think we could just do it that way. Is it like, yeah. So you could actually do it like that, but obviously this is a GUID and this wants a BSON value now, so you have to then change it into a BSON value, which is the binary one. Which obviously, if you're doing by hand, is just gets a bit crazy. So technically, that is what using the filter builders or the expressions is giving you. It's just converting it into a BSON document, saying match ID to a binary BSON data, which has a good representation of standard. So if you need to fall back into kind of like just sending like raw BSON things over the wire, you can just do that inside of Mongo as well. So when like the driver team and Mongo don't support certain things for the aggregation pipeline, you can still fall back all the time into writing them like rawly as possible to kind of like do that. So that's pretty much the two main things of kind of using Mongo with .NET. And there's this other cool thing what people quite like, and it's quite cool, but I've never actually used it in production. And it's the way to use chain streams. So chain streams are a way to like listen to changes in your database to do anything you want. So people use them for creating real-time applications. So maybe like an order is being created for a policy, and you get like a real-time push notification down to like the browser or somewhere else on somebody's desktop, or you have some other kind of processing where it sends them out email or anything else like that. That means we can just listen to like a collection or a document being inserted. So these can be like open. You can open a chain stream on a collection, a database, or cluster. So, and these read events off the oplog, and the oplog is the way Mongo replicates its data between its replica sets. So it's just like pretty much a log of kind of all the operations the database is kind of done. So that means you can also start a chain stream in the past. So I can say like, oh, start me a chain stream an hour ago. And as long as I got like an oplog for that time in the past, I'll be able to read from that oplog of kind of all the events, what happened since then. And also you can resume it. So it gives you a token to resume it at any time. So if you need to update your like application or kind of it crashes or anything else, you have a token which you kind of store somewhere else. And then you reconnect to the database and give the token, and you can just continue your stream. there's a bunch of things what you can actually listen to. You can listen to document level of things being inserted, updated, and deleted. You can listen to a collection level of things being created, dropped, indexes being created, index being dropped, things being modified or renamed, and their char keys being modified or created. And also you can list things like the database being dropped as well, and also when something's invalidated. So say you listen to inserts inside a collection, and you delete the whole collection, then it gives you an invalidated kind of type as well. So these are kind of quite useful for like either developing as a software developer when you actually listen, you might want to listen to orders of policy, or you might also be a DBA and you want to kind of monitor when your software developers push like 300 indexes to a collection, for example, and you can get like notifications real time of like saying like, oh, and a collection is being index is being added or deleted to this collection, which is quite useful for kind of just monitoring. And to kind of listen to any changes, you can just call the collection.watch, and then there's like you can just iterate over it forever using this for each async extension, which gives you the change back and just keeps going around an infinite loop. But this obviously will just get every change in the database possible, which isn't that useful, and you'll probably just saturate everything. So you normally create an aggregation pipeline because most things are built on aggregation pipelines. So you can create an empty aggregation pipeline, say where the operation type is a insert into that collection, watch the collection based on that pipeline, and then you can do things like give it some options. And this says, go get me the full document as an update lookup. So that means like every time you get a operation, an event in, you'll just go fetch the latest version of that document and then attach it to that watch. You can also get so that if you listen to a change stream which is half an hour ago and you set the document lookup to be this, you'll just get the document what it looks like now, not the one what looks half an hour ago. You can change some settings on the collection to say I want like pre and post the change, which obviously creates like a massive overhead of like kind of storage, but that's possible. And then there's a different option for this where you can say like, go give me the pre and post ones, and then you can inspect them as well. So then we can just iterate over it, get the full document, and then just print out whatever we want based on that. So it is a small demo of this. So my local instance is only using a single instance. So I'm just switching it to using Atlas. So yeah, this is my big long password. Oh, sorry. Pardon? They'll work locally as long as you got it run as the replica set. So Atlas has a CLI. Well, there's either a Docker a Docker image we can use to spin up a replica set locally. There's also a Atlas CLI, which allows you to create an Atlas cluster locally as well for development. And then there's also the Atlas, the cloud version as well. So you can actually, mine's just a single instance, which I've got spun up with the community edition, which is this one. But you can spin the replica setup locally as well. So I'm just going to run this API again. And then I've got this one running over here. Okay, cancel it. So this is connected to the database instance in Atlas for me. And I'll stick this over here. And need a bigger screen. So when I add in, yeah, oh no, another one. So if we go add in some policies into here, so we do the post. So this is not connected at all. So this is the API what we're posting to of a policy, and then every time a policy is created, we'll get an order has been created with the actual policy ID there. So that's just listening to the changes coming in, which is getting pushed down using change streams. So you can use them any way you like, really. So the code for that is pretty much what we saw on the screen. Let me get rid of all this rubbish. So this just creates a pipeline where we map an operation of insert, and then we can just watch that. And then I've just took off this full document. I'm just basically, if you don't have the full document, you can just get the keys or the keys or things what they're being queried on. But you can also project like out things as well. So you can add in other stages into this as well. So if you want to do any of the other aggregation stages, like skip ones for some reason, I don't know why you want to do that. But there's ways to do like them as well. So that's pretty much it for the like use cases. I usually go into like kind of production features, which are just the standard stuff what you expect out of a database, but people always like quiz me at the end for some reason. So Mongo has indexes. Surprise, it's a database. But it has tons of different types of indexes. So you have things that are like single field indexes, compound indexes, multi-key indexes for things like arrays. You have text-based indexes, geospatial indexes, hashed indexes. You can use hashed indexes for when you're sharding for high cardinality in your kind of shard key. Wildcard indexes are quite useful. So if you've got an address field and you want to index every single field inside that address, you can just do a star, and that'll just work. You can do partial indexes. You can do time to live as well. So if you add a time to live index on a document, when that time to live expires, it'll just delete the document out of the database. So if you've got things which you want to kind of clean up after a while, maybe it's like using some caching or kind of some timeouts or anything, you can do that. It has unique indexes. Unique indexes only work if you've got all the data inside the single shard. So if you've got it spread across multiple shards, it's not going to be able to check the uniqueness of that document across the rest of the cluster. So if you use the unique index, if you have a single sharded instance, or in a multi-sharded instance, you have to have the unique index part of the shard key. And then it uses like things like vector indexes, because that's the new cool thing with LLMs and things and RAG stuff. Also, replications by default. So you can run it locally using a single instance, but for any kind of production, including like staging and stuff like that, it's recommended to use replication. And this is to make it highly available and redundant. And it works on like a primary slave kind of replication. So you can read and write to the primary. You can only read from the secondaries. You can't send any writes to the secondaries. People also use like replication to be able to kind of do rolling kind of index as well. So you can apply an index to your secondaries and then swap your secondaries to the primary and then apply the index. So if you've got some kind of index which is going to like kill your system for a bit when you're applying it, you can just do rolling indexes and things like that. It's useful. You can also read from secondaries as well, but depending on your consistency level, it might not be consistent with the node which is doing the writes as well. And that kind of works like this. So you have like your application talking to the driver, and that just reads and writes from the primary, and then just get replicated down to the secondaries. The default kind of write concern, which is the kind of the most amount of like nodes that it writes to, is the majority now. So if you have a 3-node replica, you'll have to write to at least 2 of them before the driver acknowledges that it's actually complete. The first original versions of Mongo used to be just acknowledge. So you used to just throw like writes to the database, and if the database blew up or anything, you used to be like, yeah, whatever. And then it used to be like, well, at least write into the primary, and now it's like write to the majority. So if the primary went down, you still have your data. Or if you lost your disk or whatever, you still got your data. And then sharding is the way to kind of distribute your data across multiple machines or nodes in a horizontal fashion. So you might have 100 different shards, and all your data is spread across them. And you can shard the data in different ways. So you can tell Mongo to just shard the collection. So you can put like your policies collection on shards 1 to 10, and then 11 to 20, you can put your, I don't know, your articles collection if you want to. So you can spread your data out like that quite easily. You can move that around. Or you can base it on a shard key inside a document and it'll spread the load across them as well. Obviously, you want a key which is unique as possible. So then it gets spread more evenly across your cluster. And also you don't want like your key to be, make it so your nodes are hot and so stuff like that. So there's a bit of complication of like choosing the right kind of partition key. Yeah, so that's pretty much if you've got a high throughput system, you probably want to start thinking about sharding as well. And this is kind of how it kind of looks as well. So you have your application servers talking to a router, which has some knowledge about where your data is stored inside your clusters. And then you've got your shards at the bottom where all your actual data resides. And then you have some config servers, which also kind of store where the data resides, which the Mongo routers kind of use to kind of coordinate kind of where it's fetching it from. In the newer version of Mongo, the config servers are actually part of the shard servers as well. So because it's like quite low intense kind of operations to kind of just store some config data, they put them with the shards just to make it actually cheaper. So that's pretty much it. So a bit of recap, we talked about the documents, kind of what they look like, how they're modeled, how it represents more of that kind of like more of like an aggregate root of like kind of a domain than just like kind of spread out tables. And then we went over the usage. You can actually use EF to be like super fast to kind of get to market without kind of having any understanding of actually how it works under the hood. But then if you want to kind of like get some performance tuning, maybe use some kind of more specific kind of Mongo kind of like querying and things, you have to fall back into the driver. And then we also went across the production features. And then Mongo's got a bunch of stuff with like, which is really good for learning. So there's all the stuff's online about kind of how you use Mongo, how you set it all up. There's also MongoDB University. So if you like watching videos and kind of doing like questions and stuff like that, there's that, and you also get certificates for that. All the stuff is open source on Mongo as well, for Mongo on GitHub. You can also contribute to the drivers as well. So the driver team are pretty responsive. My name's on the list of like contributors for adding some stuff for the aggregation pipeline, and I can't remember what else, some other bits and bobs. And then there's also, if you don't want to install anything locally or run Docker or anything, you can just use Mongo Playground, which allows you to just like do some in the browser kind of like, here's a document and an example of like a query, and you can share it to people as well. But yeah, that's it. Thanks for listening. Does anybody have any questions?
Without going too much into it, how do you kind of handle when you
actually the drifts are like the schema changes. Yeah. So there's a few ways people do this. It's like, so I've always personally just written some kind of migration. So if you're appending to that schema, so maybe I've got first and last name and I add the address and add something else, that's totally fine. So you don't need to change anything. If you've got like arrays of like kind of polymorphic documents and things like that, as long as the serializer knows to just ignore things it doesn't know about, it can just deal with that as well. But if you start like renaming properties or changing types, so for example, like decimal doesn't used to be a thing inside of Mongo originally, and people used to store it as like a string and also store it as a double. So then you could actually do the like kind of like the comparisons of things to say like where the amount was over 10 because it's a double, but you wanted actually the exact representation of it, so you had to store a string. People converted them back into decimals when Mongo started sorting decimals properly. And that's, you have to write some kind of migration script to just run through all the documents and just kind of like update them. So that's one way to do it. Or there's also some other libraries like wrap the driver up and give you a way to kind of like say, this is version 1 of the document, this is version 2, this is version 3, and then you give it like a migration path. And then you can apply that at like startup to all of them. Or every single time you fetch like a document out the database and it puts into memory, it says like, oh, I'm version 1, I need to upgrade to 2, then 3, and then now I'm at the latest, then I can do my operations. So you can also do it that way as well. So there's actually 2 ways to do it. I've never done it the second way. I've always done it by just writing migrations. And the most of the time, like, you haven't really broke the schema that much. Most of the time we've just been like appending to it when we've been building things. So yeah. Yep.
Do you used to do relational?
Yeah, and I'm using SQL Server for my main job now. So I don't actually use my for every company I've been at before the one I am at the moment, I've used Mongo, and then well, actually I've used SQL Server. So we've had a mixture of being SQL Server, MySQL, Postgres, Mongo, and then some other things like table storage or DynaDB or like blob storage and things like that.
Have you got any tips on? This seems like quite a different mindset of thinking. Even things like having data in the table so you don't do as much.
Yep.
Data back to get the crap out.
Yep.
So it should be there and there, right?
Yeah, yeah.
Have you got any tips for kind of changing your mindset?
Yeah, so I think like because I've like worked in like quite a lot of microservice like architectures or even kind of modular monoliths where things don't talk to each other. Everything has a separate database, right? A lot of them are being built on the back of things like RabbitMQ or Azure Service Bus or Event Grid in Event Bus or whatever it's called in AWS. So a lot of times we've been passing around events when things change in the system. So you have to always store your own representation of the data. And that kind of fits in pretty well with like kind of Mongo. So if you've got like every time somebody creates an article, you need to go update your like kind of authors like collection with actually a new count, for example. That works quite well if you've got that kind of like eventing system in play. So having like some kind of event bus or kind of broker in the middle is quite useful. Even though like Mongo does support the change streams, I probably wouldn't use it for like most of the scenarios. Probably only in like a single bounded context to use that, not kind of spread it throughout the system. Because if you've got like, I don't know, 10 different services listening to changes on a single database and you change the schema of your database, you're going to break everything. So you probably want some kind of like other contract, like a message contract in the way of that, which is more well-defined for your domain. So yeah, probably more like that. I think the big like things what I've seen when I've kind of like been in companies or joined companies where they've used Mongo straight away is like they've like modeled the kind of data completely incorrect. So when I was at a travel company, we used to have like a thing what listened to like AdWords, and updated like kind of like what had been kind of like what the conversion rate was per AdWord, and then bid more on that AdWord. And that was modeled all in Mongo, but as like a relational database. So it worked perfectly locally for all the tests. But when you deployed it, it just like locked up, and the memory just went wee, and then just start working. So I think like modeling, understanding modeling is like quite a big thing. Even though people say it's schemaless, you still have to care about kind of the performance of kind of how you kind of things operate. And I think that's a big difference because people think like, oh, I can just like look up it does have things like lookups, which are like joins in Mongo, but they're just not as performant because it's not supposed to be built like that, right? And the same as if you're starting sharding your data out and you've got lookups between all different shards, it's just going to be a tangled mess of kind of like lookups. So yeah, there's like a bunch of stuff online which is quite good for kind of like learning about kind of how you model things. And most people go for like kind of rolling things up as much as possible, and then maybe having like some kind of hybrid approach to things as well. So, yeah. Yeah, so Mongo supports time series. So it has when you create a collection, you can create it as a time series collection, and then you give it like an automatically a timestamp to it, and it will just like roll in as well. So I don't know if his performance is like a normal kind of time series data. Yeah. 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 I think one of the benefits is that you can actually use that like aggregation pipeline on top of it, compared to like a normal time series database where you just like get like just the data back straight back out. Yep. Yep. So you can just like, so this is just whoop, let me go back into it. So this what I was doing here is just the database. So that is sending a query to the database. What? Oh, why is it doing that? Yeah, there we go. It's just stuck over here now. Yeah, so this just goes to this collection and does a find on it. So it's just doing a find, and we're just executing that, and that's doing the query in the back of it, right? But that is actually just sending that query to it, just an empty document, just like does that. But then if we want to start querying things like where the policy number is this, for example, we can do the same thing. So we can put that into here and just say where the policy is that, and it'll just get that single document back, which is a shorthand version of that instead. So, which is what we saw, when you use the builders, you get the EQ. The EQ maps to this thing down here. I can't see it as good. So yeah, so we have like EQ, and then you can have like a not equal to as well, which is any. Well, there's nothing in this one, so let's just swap to. So where it's not equal to that, you can execute that query, and that's got some which aren't equal to that policy. And then you can also do things like whether premiums greater than what we got, 300. Yeah. So if it's greater than 200, so you can say whether premium is greater than 200. It'll just give me the premiums which are over greater than 200. And there was one in the collection which was 100 or something. This one's brought back one which is 392 and 279. And then you can also then like add in, the find also has like a projection side of it as well. So if you want to just project out the policyholder, we can just do that as well. And by default, the projections inside of Mongo always pull out the ID. So if you want a bit more efficient, you can then say, "Oh, I don't want the ID." So you can tell it not to give that the ID. So under the hood, all them builders and things like that, and the thing, the EF and everything else, is just building up the Mongo query syntax for everything. And the same thing for like the update statements. The update statements have like $, operations have like $, push, which is just like that. And then you tell it what's to push into that array. So very similar to like SQL. SQL is like a language. Mongo has its own kind of like language for querying and updating. And there are all just abstractions on top of it to make it like a lot easier for you to write like more type-safe code to translate into like Mongo queries. Yeah. So you don't have to use this. There's like a thing called Compass. There's like, if they use the JetBrains stuff, they've got Data Grit which supports it. VS Code has a plugin for it, 2 plugins for it. One which is written by Microsoft and one which is written by Mongo. I don't know why there's 2. Yeah, so there's lots of. Yeah, the 3 Ts. That's a paid product as well, which does like kind of a lot of visualizations. And then if you use the Atlas product as well, you can actually just log onto the website and they give you like, when you're creating aggregation pipelines, they give you blocks which you can select each stage as well, which is quite nice. But all of that kind of just, all the UIs and stuff just bubbles down into kind of like just the raw sending BSON over the wire. Cool. Oh, thanks for listening.